Good morning, students. So, in the last class, we discussed few questions on probability. So today we will be continuing with a new topic, that is LPP. Okay, linear programming problem. So based on this topic, you may get one question in Karnataka CET from second year part. Okay, so we will begin with this. So meanwhile, see here we need to know some terms. Okay, some terms related to LPP. So if you know these terms, you can easily solve the questions based on LPP. Okay. So pay attention and keep yourself mute. So you'll not disturb the class. Okay. Keep yourself mute. Solve the questions based on. Yes. Okay. Pay attention. So in LPP, we come across some basic terms which you need to know. Okay. So in LPP, it is a process which is used to find out the what maximum and minimum. Okay, minimum value of objective function. Okay, of objective function. Okay, so this is the first I think so. Objective function, it is always denoted by what z, and this is a linear equation in two variables, ax plus by. Okay, so this is the objective function. So objective function is z is equal to ax plus by. Okay, next, second. Okay, so to find out the values of x and y, we make use of constraints. Okay, we make use of what constraints. Okay, or in simple words, the inequalities. So whatever the inequalities are given in the question, okay, they are the constraints. So using by solving these inequalities, we get the values for what x and y. Okay, and then the third corner points. Okay, corner point. Students, just off, mute yourself and listen to the class. Okay, those who are joining now, okay, mute yourself and then join the class. Don't disturb the other students. Okay, see, pay attention now. So see, first one is objective function, z is equal to ax plus by. Next, second, constraints, and third is corner points. Okay, so corner points are obtained by solving the inequalities. Okay, by solving the inequalities, we get the corner points. Okay, solving the inequalities. So when we solve the inequalities and plot the graph, okay, and then we get the corner points, and then last one is optimal solution. Okay, optimal solution. Okay, so these are the corner points, or these are the points which give us the maximum or minimum value. Okay, maximum or minimum value. Okay, so you need to know these. Okay, you need to know these points. First is objective function, next constraints, corner points, and then optimal solution. Okay, so these are some basic terms you need to know. Okay, so objective function, so in LP, what we are doing, we are trying to find out the maximum or minimum value of objective function. Okay, so this is what our important work is in this such type of questions. The main work is to find out the uh, maximum or minimum value of the objective function, and to find out the maximum and minimum value, we make use of corner points. These corner points are obtained by solving what inequalities. Okay, so out of these corner points, one value will be maximum and value may be minimum. Okay, and then one more node point you need to know. Okay, so when we are getting, see, 2 points. Okay, with maximum value. So when we are getting 2 points with maximum value, the line which is joining these 2 points, okay, the line which is joining these 2 points. So if there are 2 points P and Q, okay, which are giving us the maximum value, and then the line which is joining these 2 points, so each point on this line will give us the maximum value. Okay, so whatever the maximum value of the objective function is there, it will occur on every point joining P and Q. It will occur at every point joining what P and Q. Okay, so this node point you need to know. Okay, so when maximum or minimum value is obtained, okay, at two different points, okay, then the line joining these 2 points will, any point on that line will give us the maximum value. Okay, next we will start with the objective types now. Okay, questions. So these theory basic points you need to know. Now pay attention. We will start with the question part. Okay. Okay, so see the first question here is, okay, if x y is less than equal to 2, x is greater than equal to 0, y greater than equal to 0, the point at which a maximum value of 3x plus 2y obtained will be, okay, maximum value of what, 3x plus 2y obtained will be, okay. So four corner points are given, okay. So these 4 points are given to us, okay, 1 2 3 and 4. So you can solve this example by trial and error method. So see here the objective function is given. The objective function is z is equal to what? 3x plus 2y. Okay. So what you have to do is you have to just go on replacing this x and y value with the first, second, third, and fourth point. Okay. So when I replace 0, comma 2, see first option, if I replace z will be equal to 3 into 0. Okay. Plus 2 into 2. So it will be equal to what, 4. Next, when I substitute the second point 0 comma 0, z will be 0 only. Next, when I substitute the third point is 2 comma 0. Okay, so when I substitute 2 comma 0, z will be equal to, see, 3 into 2, it will be 6. In this function you need to replace this point, and 2 into 0, it will be 0, so the value will be equal to 6. And then when I replace it by 1 by 2 comma 1 by 2, see what will be the solution. Z will be equal to 3 into 1 by 2. Okay, plus 2 into 1 by 2. Okay. So when we add, see, it will be 3 by 2 plus 2 by 2. So 3 by 2 plus 2 by 2 is 5 by 2. Okay, and 5 by 2 is nothing but what, 2.5. So see, out of these four values, the maximum value is 6, and it is occurring at which point, 2 comma 0. So option C will be the right option. Option C will give us the right option. Okay, so this is how you can find out the maximum value of this. So maximum value is 6, and it is obtained at the point what, 2 comma 0. Okay. Yes, most of you have answered it. Madan Nayak, Abhi, and Vedvati. Yes, all three are correct. Next, we will discuss the question 2. Okay, so question number 2. So if an LPP admits optimal solution at two consecutive vertices of a feasible region, and then, okay, so see the maximum with the optimal solution of at two consecutive vertices of what, a feasible region, then the required optimal solution is at the midpoint of the line joining 2 points. The optimal solution occurs at every point on the line joining these 2 points. The LPP under consideration is not solvable, and the LPP under consideration must be reconstructed. Okay, so in this case, see, just now we discussed one important point, that is, whenever the optimal solution is occurring, see, optimal solution is occurring at what, two consecutive points. Okay, so the option B, that is the optimal solution occurs at every point on the line joining these 2 points. Okay, so see, suppose, see, pay attention. Okay, and these are the two inequalities. Okay, so first inequality and then second inequality, and see, you are getting the corner points as this. Okay, this region. So suppose this is P and this is what, Q. So we have got the maximum value at both. Okay, so line joining these points. Okay, line joining these points, any point on this line will have what, the maximum value or the optimal solution. Okay, so optimal, it may be maximum or minimum. Okay, so the right answer is answer B. The optimal solution occurs at every point on the line joining these 2 points. Okay, next. Okay, so see, next question, question number 3. Okay, next. So see, for the LPP, maximize z is equal to x plus 4y subjected to the constraints x plus 2y. Okay, x plus 2y less than equal to 2, and x plus 2y greater than equal to 2. Okay, x comma y greater than equal to 0. Okay, so here we have to find out the maximum value. So we need to follow the procedure of solving the LPP. So to find out, so see here, we will be discussing the solution. Okay, so see here, first what we have to do is we need to convert inequations into equations. So the two equations will be x plus 2y is equal to 2 and x plus 2y is equal to 8. Okay, x plus 2y is equal to 8. So see here, so see the constraints are you can see the constraints to this x plus what x plus. Okay, so see how we can solve it. So first I will explain you the method and then we will go through the solution. See, pay attention. So here what we are doing is, see, we are considering these inequalities x plus 2y less than equal to 2. Okay, and x plus 2y greater than equal to what 8. So when you simplify, we get x plus 2y is equal to 2 and then x plus 2y is equal to 8. Okay, so we need to solve these two. Okay, so when you solve these two, you will get x and y values. Okay, so some different values you will get. Okay, see, pay attention now how we can solve this one. When you try to understand, most of the examples are similar. Finding the corner points or finding the point of intersection. Okay, so such questions are there. So try to understand one question completely. Okay, so see here we have converted and we are converting and plotting it. You can see x by 2 y by 1 is equal to 1, x by 8 y by 4 is equal to 1. So see, this is the equation. This is the equation of the line. Okay, of the line x plus 2y is equal to 8. Okay, and another line is x plus 2y is equal to 8 is one line and another line is x plus 2y is equal to 2. So both the lines we have plotted and then you can see the solution region. Since they are less than equal to, it will be true, so they will be always away from the what origin to the side. Okay, so you can see there is a solution region on OC, okay, on ODC, as well as there is some solution region on what. So we can do it here. So first, after solving this, there is no common region they are saying. Okay. So see, since there is no common region, there will be no common points. Okay. And when there is no common points, we cannot find the feasible region. And once we cannot find the feasible region, we don't have any maximum value or what minimum value. Okay. So the option D will be the right answer. Okay. So option D is the right answer. Okay. Only one student has answered it. Madan. Okay. Yes. So we will go to the next question now. Question number 4. Okay. So here what we are doing is okay. So see option D. Okay. Next we will discuss the question number 4. Okay. So see here in the fourth question, what's been given? The visible region of LPP is shown in the following. Z is equal to 3x plus 4. Okay, y 9y. Then the minimum value of z cos x is the minimum value of z across at. Okay, so see here what they have done is again they have plotted a graph and the quadratic solution is present in first quadrant. Okay, and since it is present in first quadrant, we have what four corner points. These all four corner points we need to substitute. It is like the previous example in this. So when you substitute in this, see which point will be having the greater value. Okay, so once I substitute once 5 5. Okay, so I will be substituting 5 comma 5. Okay, so see, now pay attention how we can do see this one. So already corner points are given, so those corner points same as previous question we need to substitute here, and once we substitute, we can easily obtain the maximum value. Okay, so when you do this, when you substitute the first point, what will be the value? See, okay, 3 into 5 is 15, and 9 5 is 45. Okay, so next similarly, second, see, 10 comma 0 comma 10, if substitute, okay, we will be getting 0 and then 90. Okay, and 0 and 90. Third option. Okay, anybody answered this one? So one of you have answered A, another one has answered D. Okay, so we will check it. Pay attention. Yes. Okay. So see, the minimum value is Z 60 at 5,5. Okay, so the option A will be the right option. The option A will be the right answer. Okay. Next question. Question number 5. Okay, next question number 5. So see, the feasible region of LPP is shown in the figure. If Z is equal to 11x plus 7y, then the minimum value of Z occurs as. Okay, minimum value of Z occurs at. We need to calculate the minimum value. Okay, so to calculate the minimum value, okay, what we need to do, see. Okay, so see what's been given. We will discuss this. Question number 5. So say the given equations are of the form x plus y is equal to 5 and x plus 3y is equal to 9. And when you solve this, you will get the point of intersection, and that is 3 comma 2. Okay, and next what we need to do is, okay, similarly after finding the corner points, we need to substitute. So when we substitute, you can see the values are 47, 35 and 21. Out of that, least value is 21 and 20, not 20. 1. Okay, so see the minimum value will be 21. So the answer C will be the right option. Answer C will give us the right answer. Yes, Madan Nayak is correct. Abhishek, check it where you are now. Okay. Okay, next, sixth question. Corner points of the feasible region determined by the system of linear constraints are 0, 3, 1, 1 and 3, 0. Let Z is equal to Px plus Qy, where Pq is greater than 0. Conditions on P and Q. Let PQ, okay, let PQ, okay, so Z is equal to, let's say, Px plus Qy, and condition P of Q, so that the minimum of Z occurs at what, 3 comma 0. So see, already some corner points are given, and they are saying at two given points the minimum will occur. So what I will do is, first I will consider the first point. Okay, what is the first point given here? The first point is 3 comma 0. Okay, the first point is 3 comma 0, and when I substitute this 3 comma 0 in Z, what will I get? I will be getting it as 3p, okay, plus 0, or Z is equal to what, 3p. Okay, so see, we are getting this value, okay, 3p, and then q into a y means it is 0, okay, because of the condition. Next, we will be substituting 1 comma 1 in the equation. So we will get z is equal to 1 into x plus, see, 1 comma 1 we need to substitute. So it will be z is equal to p into 1 is p. Okay, p plus what? Q. So when we equate these both, what do we get? See, 3p from the first equation is equal to p plus q, or 2p will be equal to q, or p will be equal to q by 2. Okay, p will be equal to q by 2. So q by 2, option A gives us the right answer. Option A gives us the right answer. Okay, so almost most of the examples are similar and quite easy also in LPP. Okay, next we will go for some harder question, okay, which will be useful for you in JEE, okay, as well as in Karnataka CET. So see, next question, question number A7. So after this question number 6, next we will proceed with question number 7. Okay, so the shaded region is the solution of the inequalities. Shaded region. Okay, so find the shaded region. Okay, is the shaded region is the solution sets of the inequalities. So here we have to identify which equalities will satisfy. Okay, so see here what we have to do is, see, x is equal to 6. It can be written in the inequality format. Okay, we have to check. Okay, some which you know you need to check. So we know always parallel lines to y-axis are denoted by y is equal to k or y is equal to h. Okay, in that form we do not. Okay, but here see a line is parallel. See, x is equal to 6 is parallel to y-axis. Okay, and see, you can see less than or greater than we can easily identify because see the shading is towards the origin. Okay, so what I can do is I can write it as x less than equal to what? 6. Okay, x less than equal to 6. And then next, okay, next we have this region is 0 to 5 and 4 to 5. So it will be x upon 4, x upon 4 plus what? X upon 4 plus, see, when we simplify, what do we get? See, x upon 4 will be one value and another value will be y upon 5 is equal to 1. When we simplify, we get 5x plus what? 4y is equal to 20. Okay, so see, two hints we have got. One is first one, next second one, again it is towards the origin, and since it is towards the, you can see it is away from the origin. Okay, away from the origin, so it will be greater than. Okay, so it will have greater than sign away from the origin. Okay, next, okay, you can see now two equations we have got. Now for y, see, y the solution is equal to 3, so you can write it as y less than equal to 3. Okay, less than equal to 3, and you can see these all conditions: x less than equal to 6, 5x plus 4y greater than equal to 20. Okay, and y less than equal to 3, okay, are occurring in option C. So option C gives us the right answer. Okay, option C gives us the right answer. Hope you have understood the solution. Next, question number 8 we will discuss now. So two of you have answered as Madan Nayak and Vam Shri Krishna. Okay. Next example, question number 8. Okay, so see, next question number 8. So see this one, the cost and revenue of products are given. CX is equal to 30x plus 4000 and RX is equal to 60x plus what? 2000. respectively, where X is the number of items produced and sold. The value of X to earn profit is, okay, the value of X to earn what profit is. Okay, so see here what we can do. The value of X to earn profit is, okay. So in this particular question, what we can do is, first what we can do is, say if we see simple logic, okay, there is a very simple logic. So see, when a profit will be earned, okay, when a profit will be earned, okay, so profit will be equal to, see, profit will be when the profit will be when your Rx minus Cx, okay, see, R must be greater. When R is greater and Cx is smaller, and then you will have profit. Same way loss, okay, loss will be, okay, the loss part will be, say, loss part will be Cx. So when your cost price is more than the Rx, that is revenue, okay. In such cases, it will be what loss, okay. So just you have to substitute a point and check what about profit and, okay. So see here now, one value is given to us. So we can see Rx minus Cx. If it is greater than equal to 0, then only, if it is greater than 0, then only the profit can be earned, okay. So you all understood why this condition is considered Rx minus Cx, okay. So using this condition, we can simplify the example easily. So see, pay attention. So the condition here is, okay, the condition is Rx minus Cx greater than 0. So Rx value we know it is 60x, Cx value we know it is 2000. Okay, Cx plus 2000 plus x minus 20x minus what 4000x. So okay, so on simplifying we can see 40x is greater than equal to 22,000, or, okay, or you can see that on simplifying we get x is greater than equal to 50. So when you divide 40 by 2000, you will get x greater than equal to 50. So the option A will be the right option. Option A gives us the right option. Okay. Yes, two of you have answered correctly. Next question. Question number 9. Okay, it's question number 9, but this is from the other book. Okay, so see, a region represented by x greater than equal to 0, y greater than equal to 0. Okay, so the inequality, see, x greater than equal to 0, y greater than equal to 0, okay, will occur in what? It will occur in first quadrant. Yes, so in first quadrant, all the trigonometric ratios. Okay, so see, so the first quadrant, because the first quadrant is the positive quadrant. Okay, next, solution set of the inequality x greater than equal to 0 is, see, x is greater than equal to 0, x is greater than equal to 0. So if I substitute, see, 1 in place of x, so 1 will be greater than equal to 0, 2 will be greater than equal to 0. So see, it will be, see, x greater than equal to 0. Okay, you can consider x is equal to 0. If you consider x is equal to 0, okay, see the half plane, pay attention. Half plane on the left side of the y-axis, half plane on the right side of the y-axis, excluding the points on y-axis, half plane on the right axis, okay, right axis, okay, right of y-axis, including points on x and c, and none of these, okay, none of these. So we will be checking the answer for this. So see, the solution set of the inequality, the set of all the points whose abscissa and are negative, all these points lie either on y-axis or on what, or on the right y-axis, okay. So they are lying on y-axis, or they are lying with right direction of y-axis. Okay, so option C gives us the right answer. Okay, next, the region represented by the inequalities is, okay, so you need to plot the graph. I'll give you 1 minute time. Try to solve it. Okay, try to solve it. What will be the answers? Take 1 minute time and try to solve the, okay, try to solve the question. So the region represented by the inequalities. Just take 2 minutes quickly and tell me the answer. Okay, so we will check the answer. Some of you have answered it as option D. Okay, now see, pay attention here. So let L1 is x, L2 is y, 2x plus y is equal to 10, x is equal to 0, and y is equal to 0. So the graph, okay, the graph of the inequalities, see, it is bounded, it is a triangle. This region has no position in common with the region x is equal to 6. Okay, x is greater than equal to 6 and y is greater than equal to 2 as from the figure. Hence, the region of these inequalities is an empty set. Okay, and because of this, you can see the option D, that is none of this. So there is no particular figure formed. Only a triangle is formed, but some inequalities are not covered in the triangular portion. So for that reason, it can't be a polygon, it can't be a triangle. So none of these will be the right option. Okay, next question number 21. Feasible region for LPP is shown shaded in the following figure. Okay, minimum z is equal to 4x plus 3y occurs at the point. So we have to calculate the minimum. Again, same type what we have done in the first two questions. Okay, in the first two questions, whatever the yes, we have done, the same type you need to do. Okay, so solve it for homework, this 21 question. So minimum value, see, it is occurring at 2 comma 5, it is equal to 23. Next, 22nd, maxima is z is equal to 3x plus 5y subjected to, okay, subjected to x plus 4y less than equal to 10. Okay, less than equal to greater than equal to 0, sorry. So see, what we can do here, further we will solve this one. So see here, the objective function is given to us. Okay, so the objective function, we have the objective function z, and inequalities are given. So on solving the inequalities, see, we need to convert these inequalities in terms of equation. So we are getting 1, 2, 3, 4 and 5 equations. So 4 and 5 at least they will be, okay, passing, see that 4 and 5, if you see 4 and 5, just they are the non-negative inequalities, okay, and it will help us to plot the solution region in the first quadrant, okay. So now we need to solve three inequalities, L1, L2, and what, L3. So when we solve these three inequalities, okay, you can see there. So we will show these inequalities, okay. So see, from this solving these inequalities, what we are getting, see, we are getting the common solution region, that is you can see C over there, okay. It's not clearly visible here. So see, on solving 1 and 2, we get B is 6 comma 3. So this point B, you will get 6 comma 3, and similarly we get 3 comma 4, and then we will get the corner points. So shaded, okay, shaded portion O, A, B, C, D is feasible region, is a feasible region. Okay, so on simplifying, we get these corner points. So the maximum value will be what, C. Okay, the C will be the maximum value. Okay, so option C will give us the right answer. Okay, next question number 23. So in question number 23, so you can see the maximum minimum is 37, and it is occurring at 3 comma 4. Okay. Next, same type of question, maximize. So this 23rd question, you all solve it for homework. Question number 23, solve it for homework. The next question number 24 now. Okay. So see this one, you can do it for homework. It is similar as the previous question. Next, we will be discussing so 23 and 24 both are same. Okay, so try it for homework. Next, we will discuss the question number 25. Again, 25 is also same. Okay, but they are getting a two corner. Okay, 2 points as the maximum. Okay, so when you are getting 2 points as the maximum, okay, first start with first point and then start with the second point and check it. Okay, or if by both ways you are getting the same answer, then both the answer are correct. You see, next question number 25 we will discuss. So 25, okay, we will discuss the solution for this. This way the on simplifying 26th also it is similar. But here what they are doing is again they are asking the corner points only. So you need to simplify instead of x1 and y1, x and y, they have given x1 and x2 in the question. So you have to find the values of x1 and x2. Okay, x1 and x2. So you can see we have maximum z is equal to what, 10x plus 25x2 is the objective function. Then on solving the inequalities, we can see that three inequalities are given. So on solving these three inequalities, we are getting the corner points 0, then a 3 comma 0, b 3 comma 2, and d and c. Okay, so altogether 5 corner points we are getting. Okay, so once we get the corner points, next what we have to do, we have to substitute these corner points in the objective function. Okay, we need to substitute it in the objective function. So when we substitute it in the objective function, okay, when we substitute these values in the objective function, the option C will be the right option. Option C will give us the right option. Okay, next question number 26th we discuss, sorry, option D will give us the right answer for 26th. Okay, next question number 27 is also a similar question. you have to what minimum value. You have to find the minimum value. So corner points are given, equations are given. So same procedure you have to apply and find the middle person. Okay. So see what we have to do is we have again the objective function is given, inequality is given. So solve it. So on simplifying, what do we get? See, okay, simplifying, what do we get here? We are getting a unbounded region, and you can see the corner points there. Okay, the corner points are B. Okay, the corner point is B. Okay, B is the corner point, and then you can see immediately C is also corner point, and D is also corner point. Okay, D is also a corner point. So when we substitute these values, what do we get? See, when we substitute the values, we get it in the form of. Okay, see, you can see there, and they have substituted the values. Okay, and on substituting, you will be getting C as the answer there. So corner points we have found out, and then we can substitute and find the answer. Yes. See the next question now. Question number 28. Question number 28. Yes. So see, almost the questions are similar now. Okay, and such kind of questions only are asked repeatedly, or sometimes they will ask the definitions. Okay, so whatever the definitions we discussed, LPP definition, then objective function, constraint definition, and then constraint definition, feasible region definition, optimal solution definition. So such type of definition, fill in the blank type question will occur, or the question will be in the form of the questions what we have solved. Okay, so objective is given, and again three. Okay, again three inequalities are given in this question number 28. They are asking us to calculate the minimum value of z occurs at. Okay, occurs at. So here what we need to do is same way again solve the inequalities. X plus 2y greater than equal to 3, x plus 4y greater than equal to 4, and 3x plus y greater than equal to 3. So solve it. You will be getting, okay, the corner points on plotting this. See, on plotting these inequalities, we can see that. Okay, on plotting the inequalities, we can see we are getting the, okay, a region again which is unbounded. And when we solve this, okay, when we solve the corner points on substituting, we will see the minimum value is occurring at 2 comma 1 by 2. Okay, and 2 comma 1 by 2 uh, is the minimum value. Okay, similarly question number 29 also you need to calculate the minimum value. Okay, 29, same way. 30 question is also same. I try to do it for homework. Next 31 is also same, exact same. Okay, now you can see, and this is some different. Okay, yes. This is question number 30. 2 you will see. Z is equal to 6x1 plus 2y2 subject to 5x1 plus 9x2 less than equal to 90, and x1 plus x2 greater than equal to 4, x2 less than equal to 8, and y x1 greater than equal to 0, and x greater than equal to 0. Okay, so it's already same type. We will discuss the solution for this. See, minimum value, we need to find out the objective function. So on solving these inequalities, we get the corner points as D, C, B, and A. Okay, D, C, B, and A. Okay, so when we substitute these values, we can see the answers are 24, 108, 136. Okay, so these are the, and out of these, we need to check the image. Okay. Okay, so when we solve this, we will be getting these values. Okay, and on substituting, now to find out the minimum value. See, minimum value is 24. Okay, and this is occurring at the point what 4 comma 0. So that will be the answer. Okay, that will be the answer. So see, the minimum value is at 0 comma 4, and it is equal to 8. Next question number 33 is also similar one. You all do it. Next is this question. The corner points of the feasible region are determined by the system of linear constraints are 0, 10, 5, 5, 15, 15, 0, 20, and the objective function is px plus qy, where pq is greater than equal to 0. Condition on p on q, so that okay, maximum z occurs at a point, okay, occurs at a point 15 comma 15 or and 0 comma 20. So what you have to do in this equation, once we have to substitute 15 comma 15, and then we have to substitute, okay, 0 comma 20. So out of this, one will help us to get the condition for p and q. Okay, so see, first we will be substituting for z. We will be substituting the first point, that is 15 comma 15. So when we substitute 15 comma 15, what do we get? See, when we substitute 15 comma 15, it will be 15x plus 15y, and then we substitute this 0 comma 20, okay, 0 comma 20, then also we get it in the form of 20y, okay, 20y. So when we simplify these now, see, when we simplify these, what will be the answer? See, okay, so when we simplify this and solve it, we can see that, see, we will solve it here. 15x plus what, 15y we will get, and this is equal to z first case. Next, z is also equal to what, when we substitute as 20, we will get 0 and what, okay, 0, we will get a 0 first, and then we will get 15. Okay, so this is one condition. Second condition will be this is 0 plus what, 20y. Okay, so equate both. So when we equate both, what do we get? See, 15x plus 15y is equal to 20y, or 5y will be equal to what, 15x, or on simplifying we get 3x, okay, is equal to y. So y equal to what, 3x will be the right option. Okay, so y equal to 3x, but instead of y here we have q. Okay, so q is equal to 3p. Okay, q is equal to 3p. So the option D will be the right answer. Okay, next. So next, last one more question we will discuss and then stop. So here again, same type question is given. Sorry, not same type. Same type question is given. The maximum value of f is equal to 4x plus 3y subjected to the constraints x greater than equal to 0, y greater than equal to 0, 2x plus 3y less than equal to 18, and x plus y greater than equal to 10 is. Okay, so a simple question is given. Okay, you all do it for homework. Okay, so we have discussed few questions, minimum 15 questions. We have discussed 15 to 20 questions on LPP, and some PYQs also we have discussed, as well as the questions based on the concepts are been discussed. Okay, so you all once again go through the video and try to practice the examples. Okay, so we will stop here and we will meet tomorrow. So see, tomorrow I think so, because of Yugadi festival, there is slight adjustment in the timings. Okay, it will be let they will inform you. So in the morning session only the classes will be engaged. Okay, so note the time and attend the classes. So we will meet tomorrow, and take care. Bye.